Hello, I'm Tom Hollingsworth, and welcome to Networking Field Day. We're here in sunny Santa Clara, California with NEC at Networking Field Day 13. We're also joined by a group of Networking Field Day delegates around the table who represent the best and brightest minds in the networking industry as bloggers, podcasters, writers, and speakers. They have been invited to this event to take part in discussions, to ask questions, and offer their opinions on technology. If you'd like to learn more about this event series, including how to become a presenter or a delegate yourself, please go to our website at techfieldday.com. If you'd like to see more videos about technical subjects like this, please visit our YouTube channel at youtube.com/techfieldday.
Hello, for those who just joined, my name is Liviu Pinchas. I'm the product manager for NEC line of SDN products. So I'd like to preface our second demo that will deal with our cyber defense solution by describing the problems that we are trying to solve and how our solution works. I'm sure there is no need to mention what a huge problem are cyber attacks. Ransomware, theft of proprietary information, theft of banking information, and so on. A majority of organizations were affected. A majority of organizations believes they will be affected again and again. So obviously, this is an area where better things need to be done. And one of these, it's our solution. We believe that in order to secure the LAN and organization LAN, there needs to be multiple layers of security. Of course, everybody has a firewall or IDS somewhere between the internet connection and the organization, which provides good perimeter protection. But there are several cases where the firewall cannot help. The first issue are same-day attacks, when a new type of vulnerability is discovered and the virus is coming. And because this is new, the firewall is not yet programmed to defend against it. So maybe the next day we'll have this defense, but today we don't have it. So the attack penetrates the firewall and spreads inside the organization. A second issue is protection from internal threats. So somebody brings his own device, which is already infected and connected to the LAN. So he goes around the firewall, and then the threat is already inside an organization and can spread from there. So these are the two types of use case that our solution addresses. So what we have done, we are proposing a solution that combines our SDN controller with security appliances. We can work with a multitude of security appliances right now. We have done testing with SonicWall and Palo Alto. Both are our partners. And the idea is to protect against these types of threats. So let's look at the old solution. We have a firewall somewhere on the connection to the internet. The threat already penetrated the firewall or went around the firewall. And then there is a first workstation on the left that was infested. Nobody prevents this workstation of spreading the virus to other workstations inside the organization. And also nobody prevents it from uploading data to a server that is controlled by the hacker. Now, with our solution, we are extending the protection of the firewall to internal communication. So we are able to look at the internal communication, detect a certain workstation is infested, and block it. Once it is blocked, the spread of the malware it's restricted. And of course, there is a message to the network administrator that will take out of the network that particular workstation and clean it. Now, this typically is done in a manual way today. So somebody comes to the office, he notices his laptop works funny. He calls the network administrator, he comes, he cleans it. It can take hours, maybe days, till all this process happens. And while this activity is ongoing, the threat spreads to many other workstations inside the organization. Now, with our solutions, this is completely automated. So immediately the threat is detected, and the workstation is isolated, and it doesn't have time to propagate the malware inside the organization. So this is a more detailed diagram of an attack. So the attacker would send to one of the users some infested email or document, or put it on a thumb drive that the user brings to work. The victim opens the attachment file. Then his workstation is infested. And then the workstation will start communicating with the attacker and upload maybe confidential data. So this is how we solved this situation. So we can use either the main firewall, but in many occasions, the old setup remains undisturbed, and we add a second firewall, which is typically an appliance, not a physical device. It's just a firewall appliance running on one of the servers. And our programmable flow controller, between many other things, can do service chaining. It can take chunks of the internal traffic from strategic points in the network and direct it, mirror it to the firewall appliance. So we can isolate the network in small units and practically make the firewall appear that it's all around many workstations or segments of workstations. Then the firewall appliance would find the internal thread, and we have an SDN security adapter which pretty much scans periodically the logs that is generated by the firewall and looks for thread reports. The moment a thread report is located, there is a job generator that will send a command to the programmable flow controller indicating that a certain workstation with a certain IP address is infested. And the programmable flow controller will block the station, will update the ACLs of the switches, such that the workstation can no longer communicate. So now, again, Aravind will show you how this actually works.
Quick question. You said updates ACLs on the switches so that that infected host can no longer talk through the command and control network, or is it like a full quarantine? What's the behavior?
Yes, the SDN controller practically controls all the routes inside the network. So he knows each workstation where it's connected and what flows it has. So it will just block a certain flow, and the workstation is blocked. So it cannot communicate, it's totally quarantined. And then it can be taken out of the network whenever this can happen.
So that's the demo we're going to show today. The controller can also redirect traffic, for instance, into a honeypot or through a scrubber system to be able to, if there is the policy where you don't need to make that such a drastic action. So you have a lot of options there.
So is there a penalty for doing whatever kind of inspection is going on real time, constantly on everywhere in the network?
No, actually there is no penalty because the traffic is mirrored, so we don't actually block the traffic or delay it. We just mirror it, and because the network the SDN controller has a global view of the network, you can select precise points in the network where you want to mirror it. So the virtual appliance acts like many small firewalls placed all around the network.
Okay.